Welcome back to the 6 dimensions of phenotyping. This episode will focus on the 4th dimension of phenotyping, the orientation of the sensor, which we call theta. This dimension encompasses several components: the position of the light source, the angle of observation, and the orientation of the biophysical variable which we are trying to measure. Let's have a more in-depth look. First, the position of the light source. To be able to measure a signal, the signal needs a source. Either the object you're trying to measure emits a signal, this is mainly the case in the thermal domain, or it reflects and/or absorbs the signal coming from a separate light source, which is exclusively the case in the visible and near-infrared electromagnetic spectrum. A light source can be punctual or continuous, sending a directional or a diffuse signal. The characteristic and orientation of the source will create shadows and specular effects, thus have a strong impact on your measurement. Second, the position of the sensor. The characteristic of the signal highly depends on this. The best way to imagine this is by thinking of our eyes, which is the most standard sensor in the visible domain. When we look vertically at a crop, we can see a lot of soil. But if we put our eyes just above the level of the plant canopy and look horizontally, we will see mostly plant and much less soil. This means that the green fraction changes with the theta. Traits such as F-cover and phi par are examples that we'll discuss in another series focused on these and other traits. Finally, the orientation of the biophysical variable you're trying to measure can change through time. It's mainly the case when stress occurs. As an example, when the leaves droop when it's too hot or there's water deficit conditions. This is why it's so important to define a standard operating procedure that defines theta to correctly and consistently analyze images for a specific trait. This concludes our brief overview of how orientation influences the art of phenotyping. Next up, we'll surf the electromagnetic waves to understand how light influences phenotyping. At Hyphen, we process image data every day from satellites to drones to phenomobiles and smartphones. We would be delighted to hear about which traits are of interest to you in your agronomic inquiries and see if we can help you access image analysis to achieve your phenotyping goals.